Controls. Cbse acids, bases and salt. Topic. Tests to distinguish between acids and bases. Subtopic A. Indicators showing misspelled color change. Key concept. Some indicators change misspelled color in acidic or basic medium. They help us identify whether a substance is an acid or a base. Types of indicators. Natural indicator. Litmus. From lichens. Synthetic indicators. Phenolphthalein methyl orange litmus solution. Purple in neutral solution, red in acidic, blue in basic. Two types used in lab. Red litmus and grammatical error blue litmus. Example trick. Blue red is equal to acid, red blue is equal to base. Remember, Bra is equal to blue, red is equal to acid. Rob is equal to red, blue is equal to base. Subtopic B. Indicators showing misspelled odor change. Olfactory indicators. Key concept. Some indicators show different smells in acidic and basic conditions. Examples: onion, chopped, tied in cloth, smell retained in acid. Lost in base, vanilla essence, smell retained in acid. Lost in base, clove oil, different smell in acid and base. Simple trick. Smell retained is equal to acid, smell changes lost is equal to base. Remember, ORS, onion are retains in acid. S smell gone in base. Topic. Acids. Subtopic 1. General characteristic properties of acids. Key points. Sour taste. Acids taste sour. Example: lemon juice, citric acid. Litmus test. Acids turn blue, litmus red. Methyl orange test. Turns orange to red in acid. Corrosive nature. Straw in acids can burn skin and damage materials. Stored in glass or ceramic containers, not metal. Danger mark. Straw in acids like misspelled sulfuric acid have a poison or danger label. Reaction with metals. Acids react with active metals like Zn, Mg to release hydrogen gas. Examples: Zn plus H, so misspelled ZnSO plus H. Zn plus HCl misspelled ZnCl plus H. Simple trick. If it burns, bubbles, or tastes sour, it's probably an acid. Remember characteristics. SMLRCH. S sour taste. M methyl orange, red. L litmus blue to red. R reacts with metals. C corrosive. H hydrogen gas formed. Subtopic 2. Reactions of acids with carbonates and bicarbonates. Key points. Reaction with carbonates, bicarbonates. Acids react with metal carbonates and bicarbonates to form salt plus CO plus HO. Examples: misspelled Na, misspelled Co plus H, so misspelled Na, misspelled So plus Co plus HO. Misspelled CaCO, chalk, marble, eggshells, plus HCl, misspelled CaCl plus Co plus HO. Use in real life. Baking soda, misspelled NaHCO, is used to relieve acidity, acts against HCl in the stomach. Simple trick. If it fizzes or bubbles with CO, carbonate is reacting with acid. Remember reaction. Cba is equal to CO plus bubbles plus acid. C carbonate, B bicarbonate, A acid, CO gas and bubbles appear. Topic. Reactions and properties of acids. Subtopic 1. Conductivity of acids. Key point: acid solutions in water conduct electricity because they release ions. Example experiment: connect a bulb in a circuit with dilute misspelled sulfuric acid. The bulb glows, electric current flows due to ions. Simple trick: no ions is equal to no current. Acid H conducts electricity. Remember, acid is equal to ions is equal to glow. Subtopic 2. Reaction with bases. Neutralization. Key point: acid plus base, salt plus water. This is called neutralization. It removes acidic basic nature. Example: HCl plus NaOH, NaCl plus HO. Simple trick: acid and base cancel each other out. Remember, Abs W is equal to acid plus base is equal to salt plus water. Subtopic 3. Reaction with metallic oxides. Key point: metal oxides, like CaO, misspelled CoO, MgO, react with acids to form salt plus water. This shows that metal oxides are basic. Examples: CaO plus 2H close, misspelled CaCl plus HO, misspelled CoO plus 2H close, misspelled CoCl plus HO. Simple trick: metal oxide is equal to basic acid plus basic oxide is equal to neutral, salt plus water. Remember, MoSW is equal to metal oxide plus acid is equal to salt plus water. Topic: more about acids. Subtopic 1. Naturally occurring acids. Key points: some acids are found in natural sources like fruits, milk, and curd. These are called organic acids. Remember, quart malt, citric, oxalic, tartaric malic, acetic, lactic, tartaric, vinegar. Subtopic 2. Organic and inorganic. Mineral acids. Key points: organic acids, found in plants and animals, weak in nature. Example: acetic acid, vinegar, plus inorganic mineral acids, made from minerals, strong and corrosive. Examples: HCl, HSO, HNO, hydrochloric, misspelled sulfuric, nitric acids. Remember, NaOH is equal to mineral acids is equal to HCl, HSO, HNO. Subtopic 3. Uses of acids. Key points: acetic acid used in pickles, vinegar. Tartaric acid used in baking powder. Carbonic acid found in soda and soft drinks. Simple trick: remember, pickles, baking, bubbles, is equal to acids in use. Topic: chemical nature of acids. Subtopic 1. What do all acids have in common? Key concept: all acids release H, hydrogen, ions in solution. This is common to all acids, whether strong or weak. Simple trick: if it gives H, it's an acid. Remember, all acids H. Subtopic 2. Role of water in dissociation. Key point: acids show acidic behavior only in presence of water. In water, acids dissociate into ions, H and the corresponding negative ion. Example: HCl, gas, plus water H, misspelled Ac, plus Cl, misspelled Ac. Dry HCl does not turn blue litmus red. Only HCl dissolved in water shows acidic behavior. Simple trick. Dry acid is not equal to acid, water is equal to key to acidity. Remember, Wa is equal to water activates H. Subtopic 3, Ionization. Key concept. Ionization, when a covalent acid molecule, like HCl, breaks into ions in water. Representation. HCl plus HOHO plus Cl, H combines with HO to form hydronium ion HO. Final summary. Acids behave as acids only in water. This is because only in water they give H or HO ions. Without water, no ionization, no acidic property. Topic: Dilution of acids and its effects. Subtopic 1. Dilution of concentrated acids and exothermic reaction. Key points. Dilution means mixing an acid with water. It is an exothermic process, releases heat. The temperature increases when water is added to a concentrated acid. Important safety tip: always add acid to water slowly, not the other way around, to prevent splashing and heat bursts. Example reaction: HSO plus water heat plus HO plus SO superscript 2. Simple trick. AW is equal to always add acid to water. Acid water warm. Remember, dilution is hot, is equal to heat is produced. Subtopic 2. Effect of dilution on H ion concentration. Key points. When an acid is diluted, the concentration of H ions per unit volume decreases. This means the solution becomes less acidic. Remember, more water less power, more water less H less acidic. Subtopic 3. Measuring acid strength. Key points. Strength of an acid can be tested using universal indicator pH scale. These methods show how acidic or basic a solution is. Simple trick. pH 7 is equal to acid, pH 7 is equal to base, pH is equal to 7 is equal to neutral. Remember, pH measures power of H. Topic: Acids and bases. Subtopic 1. Use of mineral acids in industry. Key points. Misspelled sulfuric acid, HSO, known as the king of chemicals, used in fertilizer production, ammonium sulfate, paints, explosives, plastics, batteries. Nitric acid, HNO, used in fertilizers, ammonium nitrate, explosives, like TNT, dyes and drugs. Hydrochloric acid, HCl, used for cleaning metals, removing scale, like rust, used in leather, food, and textile industries. Remember, SHN is equal to misspelled sulfuric HNOHCl. Paints, explosives, cleaning. Subtopic 2. General characteristic properties of bases. Key properties of bases. Bitter taste like soap or neem. Soapy, feel slippery when touched. Turns red litmus blue. Turns phenolphthalein pink. Corrosive nature. Destroying bases like NaOH, KOH can burn skin. Conduct electricity like acids. Bases also produce ions in water. Neutralization reaction base plus acid salt plus water. Example, NaOH plus H so misspelled Na misspelled so plus HO. Reaction with metals bases like NaOH and KOH react with metals to release hydrogen gas. Example, Zn plus NaOH misspelled Na misspelled ZnO plus H. Remember base properties. BSSLCCRN. B. Bitter taste. S. Soapy touch. S. Turns red solution blue. Litmus. L. Litmus test. C. Corrosive. C. Conducts electricity. R. Reacts with acid. Neutralization. N. Reacts with metal. Topic. More about bases. Subtopic 1. What do all bases have in common? Chemical nature of bases. Key point. All bases, when dissolved in water, release hydroxide ions. O. This is the defining chemical property of all bases. Remember, BOH is equal to base offers hydroxide. Subtopic 2. Difference between base and alkali. Key points. Base, a compound that can react with acids to form salt and water. Alkali, a base that is soluble in water and gives O ions in aqueous solution. All alkalis are bases, but not all bases are alkalis. Vertical bar alkalis, soluble bases, vertical bar NaOH, KOH, CaO, NH₄O vertical bar bases, not soluble, vertical bar misspelled CuO, ZnO, FeO, vertical bar. Examples of alkali reactions. NH₄O plus HCl misspelled NH misspelled Cl plus HO, NH plus O, in water. Simple trick. If it dissolves in water to give O, it's an alkali. Remember, all grammatical error is are BS, but not all grammatical error BS are As. All alkalis are bases, not all bases are alkalis. Topic. Reactions and properties of bases. Subtopic 1. Neutralization reaction. Key point. Neutralization is a reaction between an acid and a base to form salt and water. Equation. Acid plus base salt plus water. Example, HCl plus NaOH NaCl plus HO. Experiment. Add HCl drop by drop to NaOH with phenolphthalein. The pink color disappears at the neutral point. Simple trick. Pink to clear is equal to neutral. Remember, A plus B is equal to S plus W. Acid plus base is equal to salt plus water. Subtopic 2. Mixing of bases with water. Exothermic reaction. Key point. When straw-in bases like NaOH or KOH are dissolved in water, heat is released. This process is exothermic. Safety tip. Always add base to water slowly to prevent splashing from the heat. Remember, BAW is equal to base grammatical error and water is equal to warm. Subtopic 3. Effect of dilution on O concentration. Key point. As water is added to a base, O ion concentration decreases. The solution becomes less basic. Remember, more water less O less basic. Subtopic 4. Delinquent nature of NaOH and KOH. Key point. NaOH and KOH absorb moisture from air and become liquid. This property is called deliquescence. Remember, misspelled Na-K loves water. NaOH and KOH absorb moisture and liquefy. Topic. Strength of acids and bases. Subtopic 1. Strong and weak acids. Key concept. Acids release H ions in water. The strength of an acid depends on how completely it ionizes. Strong acids. Complete ionization in water. HCl, HNO, HSO, written with a single arrow toward ions. Examples: HCl plus HOH plus Cl, HSO plus HO2H plus SO superscript 2. Weak acids. Partial ionization in water. CH2, HCO, HPO, HCO, written with double arrows. Examples: CH2 CH2 plus H, HCO superscript 2 plus 2H. Trick to identify. Strong is equal to more H, weak is equal to less H. More H is equal to stronger burning taste or reaction. Remember, SHW is equal to strong H, full, weak, partial. Subtopic 2. Basicity of acids. Key concept. Basicity is the number of replaceable H ions per molecule of acid. Enter table. 4/2. Acid basicity: HCl, HNO1, monobasic, HSO, 2, dibasic, HPO3, tribasic. Exit table. Subtopic 3. Strong and weak bases. Key concept. Bases give O ions in water. Strength of a base depends on how completely it ionizes. Strong bases. Complete ionization. NaOH, KOH, written with a single arrow. Example: NaOH plus HO, Na plus O. Weak bases. Partial ionization. NH₄OH, CaO, written with double arrows. Example: NH₄OH plus O. Trick to identify. Strong base more O, weak base less O. Remember, Bo is equal to base O, weak. Topic: expressing acidity or alkalinity using pH. Subtopic 1. Concept of pH. Key points. pH is the measure of H ion concentration in a solution. Defined misspelled as misspelled pH is equal to log H. It tells us whether a solution is acidic, basic, or neutral. Trick to understand. More H lower pH more acidic. Less H higher pH more basic. Remember, pH is equal to power of H. Subtopic 2. Ionic product of water. Kw. Key point. At 25 degrees C, H times O is equal to 1 times 10 superscript 1. This means knowing one, H or O, helps calculate the other. Subtopic 3. Measurement of strength of acids and bases. pH measurement. 2 methods. Using universal indicator. pH paper shows color changes corresponding to pH values. Paper strip is dipped into the solution and compared with pH color chart. Example: red, pH 1.3, is equal to strong acid. Green, pH 7, is equal to neutral. Purple, pH 12.14, is equal to strong base. Using pH meter, gives accurate digital value of pH. Used in labs for precise results. Simple trick. pH 1 is equal to very acidic, pH 7 is equal to neutral, like pure water. pH 14 is equal to very basic. Remember, pH scale is equal to strip color. It's level evaluation. Topic: Role of pH in everyday life. Subtopic 1: pH in biological systems, humans, animals, plants. Key points: human body, pH of blood, 7.35 to 7.45. Fall below 7 or rise above 7.8 can be harmful. Acid rain. Normal rainwater pH is equal to -5.6, due to Co. If pH 5.6, acid rain damages buildings, plants, aquatic life. Soil pH. Crop growth depends on specific soil. Misspelled pH misspelled. If too acidic, basic, growth is reduced. Subtopic 2: pH in digestion. Stomach produces HCl, helps digestion. Antacids like milk of magnesia, MgO, neutralize excess acid. Subtopic 3: tooth decay. Bacteria produce acid, lowers pH 5.5. Enamel corrosion. Toothpaste is basic to neutralize the acid. Subtopic 4: animal and plant defense. Bee sting injects acid, use baking soda, misspelled NaHCO, to neutralize. Wasp sting is basic, use vinegar, acidic, to neutralize. Subtopic 5: factory waste and lakes. Acidic waste is neutralized with lime before disposal. Subtopic 6: metal vessels and pH. Tarnished copper vessels cleaned using acid, like lemon juice, to remove oxide layer. Remember: bad stamp. B body pH. A acid rain. D digestion. S soil pH. T tooth decay. A animal sting. M metal cleaning. P pollution control. Topic: salts and their formation. Subtopic: definition and examples. Key concept: salt is equal to compound formed by reaction of acid plus base. Contains positive ion, cation, and negative ion, anion. Trick: acid gives the negative ion, anion. Base gives the positive ion, cation. Remember: salt is equal to A plus B. Acid anion plus base cation is equal to salt. Topic: families of salts. Subtopic 1: classification based on acids. Salts are classified into families based on the acid used in their formation. The name of the salt family depends on the acidic part, anion, of the salt. Chlorides formed from hydrochloric acid, HCl, general name, chloride. Nitrates formed from nitric acid, HNO, general name, nitrate. Sulfates formed from misspelled sulfuric acid, HSO, general name, sulfate. Examples: enter table. 2/3, salt base involved, salt formed, MgO, magnesium hydroxide, row 2 of 2, column 3 of 3, magnesium sulfate, misspelled MgSO. Exit table. Carbonates formed from carbonic acid, HCO, general name, carbonate. Examples: enter table. 2/3, salt base involved, salt formed, KOH, potassium hydroxide, potassium carbonate, KCO. Exit table. Remember the salt families: misspelled chan, misspelled sock, POA. C chlorides, HCl, N nitrates, HNO, S sulfates, HSO, C carbonates, HCO, P phosphates, HPO, O oxalates, Q, A acetates, CHQ. Topic: pH of salt solutions. Subtopic: Salt hydrolysis and pH key concept. When salts dissolve in water, they may produce neutral, acidic, or basic solutions, depending on the acid and base from which the salt is formed. Salt of stroin acid and stroin base examples: NaCl, No, misspelled Na, misspelled So. Reaction: NaCl plus HO, NaOH plus HCl, both stroin. Neutral solution pH is equal to 7. Simple trick. Stroin cancels stroin neutral. 2. Salt of stroin acid and weak base. Examples: misspelled NH, misspelled Cl, misspelled CoSO, misspelled AlCl. Reaction: misspelled NH, misspelled Cl plus HO, NH₄OH, weak, plus HCl, stroin. Acidic solution pH 7. Simple trick. Stroin acid wins acidic. 3. Salt of weak acid and stroin base examples: misspelled Na, misspelled Co, misspelled CH, misspelled CONA. Reaction: misspelled Na, misspelled Co plus HOH, Co, weak, plus NaOH, stroin. Basic solution pH 7. Simple trick. Stroin base wins basic. 4. Salt of weak acid and weak base. Examples: CH-Coon reaction, CH-Coon plus HO, CH-Co plus NH₄OH, both weak. Nearly neutral pH 7. Simple trick. Weak versus weak is equal to close to neutral. Remember pH nature. S is equal to 7. Sa Wb is equal to 7. WASB is equal to 7. WW is equal to -7. S is equal to stroin acid plus stroin base neutral. Sa Wb is equal to acid wins acidic. WASB is equal to base wins basic. WW is equal to both weak nearly neutral. Topic: common salt. Sodium chloride, NaCl. Subtopic 1. Chemical name and formula. Chemical name: sodium chloride. Formula: NaCl, also called table salt, misspelled iodized salt, contains potassium iodide, KiO, to prevent misspelled gota, thyroid disease. Subtopic 2. Occurrence and extraction sources of common salt. Seawater main source in coastal cities like Mumbai and Chennai. Salt extracted by evaporating seawater under sunlight in shallow tanks. Impurities: misspelled MgCl, misspelled CaSO, removed by purification. Rock salt, found underground in crystal form. Pink color due to impurities. Example: misspelled Khevra salt mine, Pakistan. Lake brines: salty lakes like Sambar Lake, India. Great Salt Lake, USA. Remember, Sea Rock Lake is equal to SRL. Sources: seawater, rock salt, lake brine. Subtopic 3. Properties of common salt. Color: white crystalline solid. Melting point: 800 degrees C. Solubility: soluble in water. Hygroscopic nature: absorbs moisture from air on heating with HSO. NaCl plus HSO, misspelled NaHSO plus HCl, gives off hydrogen chloride gas. Subtopic 4. Reactions of common salt with silver nitrate. NaCl plus misspelled AgNO, AgCl, white precipitate, plus misspelled NaNO, Used to test for chloride ions. Subtopic 5. Uses of common salt. Essential in diet. Preservative for pickles, meat, fish. Freezing mixture used with ice to lower temperature. Industrial use. Soap manufacture. Glazing. Pottery. Raw material for other chemicals. NaOH. Caustic soda, misspelled NaHCO. Baking soda, misspelled Na, misspelled Co. Washing soda, bleaching powder, chlorine gas, hydrochloric acid. Remember uses. Salt, FIPR. S. Soap making. A. Acid production, HCl. L. Lower freezing point. T. Table use. Food. F. Food preservative. I. Industrial raw material. P. Pottery glazing. R. Raw material for other chemicals. Topic. Caustic soda, sodium hydroxide, NaOH. Subtopic 1. Chemical name and formula. Chemical name: sodium hydroxide. Formula: NaOH. Common name: caustic soda. It is a styrene base. Subtopic 2. Manufacture of caustic soda. Chlor-alkali process. Key concept: raw material, brine, aqueous NaCl solution. Method: electrolysis of brine. Apparatus: Kastner-Kellner cell reactions. NaCl, misspelled Ac, plus HO, L, Na plus Cl plus H plus O, at cathode. NH₄OH plus 2EH, hydrogen gas, at anode. Plus 2Cl Cl plus 2E, chlorine gas. Overall reaction: 2 NaCl plus 2HO, 2 NaOH plus Cl plus H. Products of chlor-alkali process: NaOH caustic soda, Cl chlorine gas, H hydrogen gas. Remember, NaCl plus HO, NaOH plus Cl plus H. Brine gives 3 important products. Subtopic 3. Uses of the products. Remember, misspelled chana claps. C. Chlorine. H. Hydrogen. Na. Caustic soda. Claps because they are used in cleaning, lab, agriculture, plastics, soap. Topic. Uses of industrial products from chlor-alkali process. Subtopic 1. Uses of hydrogen, H. Key points: used in making ammonia for fertilizers. Can. Ammonium sulfate. Used in hydrogenation of oils. Vanaspati ghee, margarine. Metal refining removes oxygen from metal oxides. As rocket fuel. Liquid hydrogen plus liquid oxygen. Remember, Fe is equal to fertilizer. Artificial ghee, industry. Metal, rocket. Subtopic 2. Uses of chlorine, Cl. Key points: water sterilization, swimming pools, making bleaching powder and disinfectants, e.g., DDT, used in production of CFCs, refrigerants, bleaching of wood pulp and cotton, making PVC plastic, e.g., shoe soles, in pesticides manufacture. Remember, swipe P is equal to sterilization, whitening, bleaching, insecticide, PVC, explosives, powder, bleaching. Subtopic 3. Uses of hydrochloric acid, HCl. Key points: used in gold purification, with nitric acid, textile industry for processing fabrics, cleaning agent, medicines and cosmetics. Remember, GTCM, is equal to gold, textile, cleaning, medicines. Subtopic 4. Uses of caustic soda, NaOH. Key points. Making soaps and detergents. Metal cleaning used in the paper industry. In rayon misspelled fiber production. Petroleum refining. Making cotton unshrinkable. Laboratory reagent. Remember, soap misspelled crumple, soap. Oil refining, artificial fibers, paper cotton, shrink-proof, reagent, metal cleaning. Topic: bleaching powder, calcium oxychloride misspelled calcal. Subtopic 1. Chemical name and formula. Common name, bleaching powder. Chemical name, calcium oxychloride. Formula, misspelled calcal. Subtopic 2. Principle of manufacture. Hasenpulver's plant. Preparation. Raw materials. Slaked lime, CaO, chlorine gas, Cl. Reaction, CaO plus Cl misspelled calcal plus HO, bleaching powder plus water. Chlorine is a byproduct from the chlor-alkali process. Remember, lime plus Cl is equal to bleach plus HO. Subtopic 3. Properties of bleaching powder. Appearance: pale yellowish white powder. Smell: strong smell of chlorine. Solubility: limited in water. Releases chlorine on reaction with co-dilute acids, like NH₄OH Cl. Example reactions: misspelled calcal plus CO, misspelled CaCO plus Cl, misspelled calcal plus HO, misspelled CaSO plus Cl plus HO. Subtopic 4. Uses of bleaching powder. Key uses: textile industry for bleaching cotton and linen. Paper industry for bleaching wood pulp. Laundry to whiten clothes. Disinfectant for sterilizing drinking water. Oxidizing agent releases nascent oxygen. Chloroform preparation: misspelled calcal plus HO plus CHQ, misspelled CHCl. Remember, TPLDOC. Textile, paper, laundry, drinking water. Oxidizer, chloroform. Subtopic 5. How bleaching is done. Steps: fabric dipped in bleaching powder solution passed through a tank of dilute HCl or HSO. Chlorine is released, which bleaches the fabric. Excess chlorine is removed by sodium thiosulfate. Topic: baking soda. Sodium hydrogen carbonate, misspelled NaHCO. Subtopic 1. Chemical name and formula. Chemical name: sodium hydrogen carbonate. Formula: misspelled NaHCO, also known as sodium bicarbonate. Main component in baking powder. Subtopic 2. Principle of manufacture. Solver process. Raw materials: NaCl, common salt, NH, ammonia, CO, carbon dioxide, HO, water. Key reactions: NH plus CO plus HO plus NaCl, misspelled NH, misspelled Cl plus misspelled NaHCO. Misspelled NaHCO is sparingly soluble and precipitates out. 2 NaHCO, misspelled Na, misspelled CO plus HO plus CO. Remember, NH plus CO plus salt is equal to baking soda plus ammonium chloride. Subtopic 3. Properties of baking soda. Color and state: white crystalline solid. Stability: stable in air. Solubility: sparingly soluble in water. Alkaline nature: due to hydrolysis misspelled NH₄OH plus HO NaOH plus HCO. Thermal decomposition, on heating, 2 NH₄O misspelled CO plus HO plus CO. Reaction with acids, misspelled NH₄O plus HCl NaCl plus HO plus CO. Brisk effervescence. Remember, white, weak, warm CO, white solid, weak base, on warming gives CO. Subtopic 4. Uses of baking soda. Key uses. Medicine as an antacid, neutralizes acid in the stomach. Cooking makes dough soft and fluffy. Fire extinguisher reacts with acid to produce CO, putting out fire. Washing soda production used to make misspelled CO. Cleaning agent used in mild household cleaning. Remember, MAFC. Medicine antacid fluffy food. Washing soda cleaning agent. Topic: washing soda. Sodium carbonate misspelled Co.10HO. Subtopic 1. Chemical name and formula. Chemical name: sodium carbonate decahydrate. Molecular formula: misspelled Co.10HO. Other forms: misspelled Co.HO monohydrate. Misspelled Co.anhydrous form, called soda ash. Subtopic 2. Principle of manufacture. Solver process. Raw materials: NaCl, common salt, NH, ammonia, CO, carbon dioxide. Misspelled CaCO, limestone. Key steps: formation of sodium hydrogen carbonate NH plus CO plus NaCl plus HO misspelled NH₄O plus misspelled NH misspelled Cl. Heating sodium hydrogen carbonate to NH₄O misspelled CO plus HO forms soda ash. Recrystallization misspelled Co plus 10HO misspelled Co.10HO. Washing soda. Remember, cold heat water is equal to washing soda. Cold forms misspelled NH₄O. Heat gives misspelled Co. Water adds 10HO. Subtopic 3. Properties of washing soda. Appearance: transparent white crystals. Efflorescence: loses water of crystallization in open air. Solubility: soluble in water. Solution is alkaline. Alkaline reaction: turns red litmus blue. Thermal decomposition: misspelled Co.10HO misspelled Co plus 10HO, on heating. Subtopic 4. Chemical reactions with acids. Misspelled Co plus HCl NaCl plus HO plus Co. With hard water, removes hardness. Misspelled Co plus misspelled CaCl misspelled CaCO plus 2 NaCl, forms insoluble calcium carbonate. Subtopic 5. Uses of washing soda. Key uses: softening hard water, laundry cleaning agent, glass, soap, and paper industry. Laboratory reagent, making baking soda. Remember, salt wash, S. softening water, A. alkali in cleaning, L. lab use, T. textile, soap, glass. Wash clothes. Topic: washing soda. Misspelled Co.10HO. Subtopic: key properties of washing soda. Appearance: transparent crystalline solid. Formula: misspelled Co.10HO. Efflorescence: on exposure to air, it loses water of crystallization and becomes white powder. Monohydrate: This process is called efflorescence nature in water. Its aqueous solution is alkaline. Turns red litmus blue on heating. Forms anhydrous misspelled co with acids. Reacts to form co with brisk effervescence. Reaction misspelled co plus HCl NaCl plus HO plus co. Subtopic: Uses of washing soda. Sodium carbonate. Laundry. Removes grease and dirt from clothes. Softens hard water. Industrial use. Used in the manufacture of glass, soap, paper, borax, caustic soda, etc. Water treatment. Removes permanent hardness by reacting with Ca superscript 2 and Mg superscript 2 ions. Laboratory reagent. Used for acid-base titration and as a standard solution. Remember, GLAD, G glass and soap industry. L laundry. A alkaline in water. D dehardening of water. Removes hardness. Here is a simplified and structured lecture note on plaster of Paris. Misspelled CaSO.2HO. Based on your shared textbook images. These notes are ideal for both students and teachers. With short points, real examples, and an easy mnemonic. Topic: Plaster of Paris. Misspelled CaSO.2HO. Subtopic 1. Chemical name and formula name. Plaster of Paris, POP. Formula. Misspelled CaSO.2HO, also called calcium sulfate hemihydrate. Contains half molecule of water of crystallization derived from gypsum. Misspelled CaSO.2HO. Subtopic 2. Preparation of plaster of Paris method. Heat gypsum at 150 degrees C. 423 K. 3/4 of the water is removed. Plaster of Paris is formed. Reaction. Misspelled CaSO.2HO. Heat at 150 degrees C. Misspelled CaSO.2HO plus 1/2HO. If heated above 200 degrees C, dead burnt plaster is formed. Cannot set again. Subtopic 3. Properties of plaster of Paris. Color and form. White powder. Water reaction. On adding water, forms gypsum. Misspelled CaSO.2HO. Again. Sets into a hard mass in 10-15 minutes. Expands slightly while setting. Useful for misspelled molding. Reaction. Misspelled CaSO.2HO plus 1/2HO. Misspelled CaSO.2HO. Subtopic 4. Uses of plaster of Paris. Applications. Medical. To set fractured bones and make surgical casts. Decorative items. Toys. Statues. Misspelled jewelry. And cosmetic. Misspelled molds. Smooth surfaces. For walls and ceilings before painting. Interior design. Decorative false ceilings. Wall designs. Pillars. Chalk making. For writing on blackboards. Laboratory use. Seal gaps in flasks. Stoppers to make airtight. Fireproofing. Used in fire-resistant materials. Remember. Mold caps. M. Medical cast. O. Ornaments and statues. L. Laboratory use. D. Decorative designs. C. Chalk. A. Airtight seal. P. Painting base. S. Smooth surfaces and fireproofing.